Welcome to CE 402 Environmental Engineering 2, Module 6, Part 6. In this session, I am going to discuss about the sludge drying beds. This is a final procedure for the sludge disposal process, that is the sludge dewatering, that is done by these sludge drying beds. This is a physical unit, that is the excess water present in the sludge after conditioning is removed from the stage, and this will reduce the volume of the sludge and which can be disposed of very easily in the other disposal methods. The dewatering is accomplished either by air drying in sludge drying methods or by mechanical means such as vacuum filtration and pressure filtration, etc. The selection of the method depends upon such factors, that is cost and cost of operation, land area available, proximity of the residences, climate, size of the plant and number of operators, plant loading, type of plant and topography. If the land available is large, then we can adopt the sludge drying beds, because the area required for the sludge drying beds is very large. And if we have the space restrictions like proximity of residences, and if we have the climatic changes, that is if it is a humid condition or cold countries, then we have to go for another method, that is mechanical method of dewatering. In India, most of the parts of the country, there is favorable climate for the action of this dewatering, that is sludge drying beds. And the purpose of sludge dewatering is cost of trucking sludge to ultimate disposal site will be very easy. That is, the volume of the sludge will be reduced after the dewatering process, and the handling also will be very easy. And ease of handling, that is dewatered sludge, then increase in calorific value, that is it is densified after dewatering. The sludge will be densified, and prior to this will help the action of incineration, then rendering the sludge totally odorless and non-putrescible. And a sludge dewatering is commonly required prior to landfilling to reduce the leachate production at landfill site. By reducing the water content in the sludge for final disposal, it will reduce the leachate generation in the landfill sites. Then the sludge dewatering methods, that are sludge drying beds, and this is used where land available is adequate, and dried sludge is used for soil conditioning. And the sludge is applied on the bed of the sand, and this is supported by the sand bed is supported by gravel, and this is a pure physical operation, and the major portion of the liquid will be drained off after a few hours of the application, and the other part will be escaped out or dewatered out by evaporation. And the sludge cake will shrink and producing cracks on the surface of the sludge bed, that is sludge drying bed. And in dry region, generally the sludge will get dried within 2 weeks. The drying period will depend upon the sunshine, that the temperature condition, rainfall, wind velocity and relative humidity, apart from the sludge characteristics. And at the adverse weather condition, that is if humidity is large, there is a intermittent rainfall is there, then the sludge drying process will delay up to 4 weeks. The sludge drying bed should be located at least 100 meters away from houses to avoid smelling problem. And the digested sludge is disposed on a well-drained sand and gravel bed. Thickness of the sludge layer is usually 1.5 to 15 to 20 centimeter. The water content of sludge can be reduced up to 70%, while the sludge volume can be reduced up to more than 60%. This is the plan view of a sludge drying bed. You can see the sludge inlet pipe here, and the dewatered water is collected at the perforated water under drain, and this perforated water under drain is connected to both sides, and you can see the hopper bottom of this sludge drying bed, which will enhance the drainage of water into this water under drain. You can see the section of these sludge drying beds. Here you can see the gravel is placed at the bottom of the sludge drying beds, and open and at the top of this gravel, sand layer is placed. Over this sand layer, the sludge is disposed of, and this sand layer will filter the water content from the sludge layer, and finally it will be collected at the perforated underwater drain. Then the next method, that is vacuum filtration. Vacuum filtration is done to reduce the water content of raw, digested or elutriated sludge in order to increase the proportion of solids from 5 to 10 percentage to 30 percentage. And with the higher percentage of solids, the sewage sludge become moist cake and it is easy to handle. And vacuum filtration is accomplished on a cylindrical drum filters. This drum is fitted with a filter medium made of synthetic fibers, coil springs or wire mesh fabric. As the drum with the dips into the tank sludge rotates slowly, part of its circumference is subjected to an internal vacuum, hereby drawing sludge to the filter medium. And the water is drawn through the porous filter cake for that the sector of the circumference. And the piping arrangement within the filter permits the suction to be maintained by blowing compressed air through the medium till the release of cake to scraper for discharge. The filter medium is kept washed in the small sector before next suction. You can see the operation of a cylindrical drum filter. Here you can see three zones. That is, first zone is the wash zone. Second zone, you can see it is the dewatering zone. And in the dewatering zone itself, you can see the discharge zone also. Then the main zone is the cake forming zone. Here you can see the stirring devices and the cake saturated with the filtrate, that the filter layer you can see the filter drum, and the rotating valve you can see here, and this is the operation of a cylindrical drum filter or a vacuum drying. Then elutriation. Elutriation is literally a washing of the sludge. This washing of the sludge is done in order to avoid the amino ammonia nitrogen present in the sludge, and which will interferes with the conditioning process of this sludge. So in order to avoid its presence, the elutriation is done. That is, again, the sludge collected from this desludging process, after desludging process is elutriated, and then sent for this conditioning process. Then the design criteria for sludge drying beds. The bed surface area required for digested primary sludge is 0.1 to 0.25 meter square per capita. And for digested primary and activated mixed sludge, it is 0.15 to 0.28 meter square per capita. And here you can see the sludge drying time, that is 2 to 4 weeks, and size of the bed is 6 to 30 meter length and 3 to 8 meter width. Specific sludge solid loading rate, it is 50 to 210 kilogram per meter square per year. This is the design criteria for sludge drying beds. I hope you understood the sludge dewatering and sludge drying beds. That is two types. That is normal sludge drying beds and then mechanical sludge drying methods. I hope you understood. Thank you for listening. See you in the next class.